Hello, my name is Arun Vamori. I'm with the DHS Science and Technology Directorate. Thanks for joining our webinar today discussing the results of the Biometric Technology Rally for 2019. This webinar in particular is about the system results for matching systems. So as you may recall, the Biometrics Rally tested both collection systems or acquisition systems as well as matching systems. And this webinar is specifically focused on the matching system results. Today I'm joined by my colleagues Yevgeny Sorotin, Jerry Tipton, and John Howard. Let's go ahead and jump into the slides. I think we have a lot of information to share with you, and I'd like to make sure we provide as much information as possible. So just very briefly, the webinar today will be broken up mostly by providing some background and history. What is the S&T Biometric and Identity Technology Center? What are the Biometric Technology Rallies? What were we doing with the 2019 Biometric Technology Rally? How were we measuring performance, and then specific results for different biometric modalities, collection systems, and matching systems. And that they will include fingerprint, iris, face recognition, and then we'll wrap up with some summary conclusions and some observations. So again, the S&T Biometric and Identity Technology Center is a group of subject matter expertise within DHS Science and Technology. The goal is to help facilitate the learning curve for DHS and its mission partners to become more familiar with and aware of new and emerging biometric and identity capabilities, to understand how they may apply to various missions, so that organizations that rely on these technologies and have these different mission areas can figure out whether or not these technologies may be useful or applicable for their specific needs. The goal truly is to facilitate information sharing and accelerated use of the technologies if it's appropriate. And we follow this approach where we focus on building once but then use or share information widely. The goal is really to drive efficiencies, to make this as easy for groups to understand how to effectively adopt these technologies quickly and do it well. Right now, a lot of our focus is on test and evaluation and talking about how to recognize some technologies that may be very promising for different needs, and today we'll focus more on the Biometric Technology Rally. So the Biometric Technology Rally is an engagement between S&T and industry, primarily focused on identifying how well specific technology offerings provided or solutions may support important DHS use cases. In this particular case, a lot of our focus has really been on this need for high throughput biometrics. And what we mean by that is the ability to recognize people very quickly with minimal staffing in a very small space in a small amount of time. The goal is to be able to support anything like either border crossings, transportation security, different security arenas or venues, to be able to quickly recognize known individuals and without having to have a significant staffing requirement. So we're really trying to focus on trying to recognize hundreds or maybe thousands or tens of thousands of people very quickly. With the rally, what we are doing is kind of defining these use cases, defining specific measures or metrics that we're trying to orient industry to, and setting goals for them to meet these things in order to help hopefully be applicable to different DHS users' needs. The 2019 rally in particular, again, is focused on this high throughput use case. It's a little bit different from the rally we ran last year. Last year, all of the systems had to provide at a minimum at least one face image, or multiple face images. This year was a little bit different because we also widened the scope so that we could also receive applications from companies that were focused on either high throughput fingerprint systems or high throughput iris systems also. Of course, multimodal systems, whether it was some combination of finger, face, or iris, were also open to participate. We also opened up a new category for participation. It wasn't just for collection systems or acquisition systems. We also were encouraging companies to submit matching algorithms so that we could help evaluate both the matching or the collection side of the capability as well as how well the images that were collected could then be matched with different algorithms. One of the things we're looking at doing here is helping stakeholders to understand that there's a breadth of opportunities or a breadth of capabilities that are out there, both on the collection systems but also on matching algorithms. And by looking at how well maybe a collection system works across matching algorithms, or how well a matching algorithm can take in images from many different types of collection systems, we get to this concept of having a robust system. Depending on your specific use case or your specific need, having this robustness may or may not be important. But if you could imagine a system where maybe there is one matching algorithm that's used by a lot of different users, but every user has a different camera, you want to make sure that your results will work really well, even though the images that your system is going to be matched to may come from different cameras. So you want to make sure that your systems will interoperate well, and that the matcher will be very robust to those different algorithms, those different collection systems. So with this webinar, we'll actually spend quite a bit of time talking about this idea of robustness of algorithms to collection systems, as well as potentially collection systems to algorithms.
Before we get into the details of the results, we do want to go back and provide a brief description of what the test was, the rally. And for acquisition systems, we had some minimum requirements. One is that it operate in an unmanned mode, and it must operate in a physical footprint of 6 by 8 foot. It could collect either face, iris, fingerprints, or a combination of the three. And it needed to provide at least one biometric image back per volunteer. It needed to do so in time constraints which were defined by DHS. Optionally, it could send up to 3 face images back, or 3 pairs of iris images, or 3 sets of fingerprints with up to 5 fingerprints each. For matching systems, they had to provide us their algorithm, their matching service, in a Docker file that we could load onto our Maryland test facility systems. It had to contain a commercially available matching algorithm. It had a size limit of 1.5 gig in size, and it had to process templates in less than 1,000 milliseconds. Along with that is it needed to be able to operate without having to contact externally or phone home for a period of 1 year. And it needed to operate on a limited set of resources. So we offered 4 CPUs, 2 gigabytes of RAM, and the algorithm could not require a GPU. In addition to that, we had an open API document that we made available to them that these vendors could test with in advance of sending us their algorithm, which they did. And all specs of this are working in an example that was hosted and still is currently hosted at our github.mdtf.org website. For the rally, we announced the call for participation in November of 2018, and we accepted the applications through the end of that month, and we provided a conditional acceptance in early February. We also provided the cloud-based API for these vendors to start working with in that February timeframe, and once they completed a set of requirements, we provided final acceptance notification in March. In May, we actually held Stakeholders VIP Day, which many of you attended, and we started the data collection and completed it in early May. And since that time, the team has been performing the analysis of that said data. For matching systems, we received 22 applications, and we accepted 15. The evaluators came from the Department of State, IARPA, DOJ, NIST, and DHS S&T. These 15 matching systems included 8 face algorithms, 4 iris algorithms, and 3 fingerprint systems. Today, the results that you hear are based upon matching systems, but there's also an interaction with the acquisition system devices that's very important that you'll be hearing about as well. With that, I'll turn it over to John Howard to talk about the acquisition process.
Thanks, Jerry. As Jerry mentioned, we know this is the matching system webinar, but we sort of think it's important that everyone understand how we collected the images we used to evaluate the matching system. So we're just going to go through the sort of acquisition test process really quick. What you see on slide 10 is sort of broadly what the acquisition systems were designed to do. The dark gray box on the left-hand image is that 6 by 8 foot space that Jerry mentioned. The acquisition system providers came to the Maryland test facility in early May. They had 2 days. They were able to put whatever they wanted in terms of sensors and cameras and instructions inside that space as long as it was safe for our participants. And then we brought about 400 people through and sort of queued them through the process you see on the left-hand side. And the right-hand side is sort of actually a picture of what that looked like. Basically, groups of about 15 would queue up in front of the system. They'd be scanned one at a time into kind of the broader test station. At some point, they would approach the acquisition system crossing a beam break. They would do whatever they were instructed to do with the system. The system would send us images, either faces, fingers, or irises, via this common acquisition system API. The test volunteer would leave the station, tripping another beam break, and then they would rate their experience with this satisfaction kiosk. The ground truth identification information, which comes off the wristband scan there at step 2, and the images that were sent via the API during this interaction are what we used as our probe images for evaluating the rally matching systems. The last thing I'll sort of mention from a test process standpoint is that before all of the test groups entered the bay, they were given general instructions that each one of these acquisition stations were going to collect biometric images for the purpose of performing an identification. But they weren't trained specifically on how to use any of these systems. So they were sort of naive users approaching each different acquisition system. So they didn't know where to look necessarily, how to interact with the system, et cetera. We also collected, prior to all of this test process taking place, what we would call same-day ground truth images. So we had a manned enrollment station with a trained biometric collector take a really good picture of each subject's face, a really good picture of each subject's irises, and a really good picture of each subject's fingerprints. So we knew sort of what they looked like, what each one of those biometric samples looked like prior to the interaction with all these different acquisition systems. A couple of other considerations we took into account just to make sure that the test was sort of fair and broadly applicable. Our sample size, which we'll talk a little bit more on the next slide, was over 400 people. That's not a gigantic sample size. It's not like NIST level, millions of images testing, but it is pretty good. It allows us to sort of get down and report results with a plus or minus 0.5% precision. Our demographics, our population is very diverse. We have all sorts of ages, genders, races, and people with sort of prior experience coming to the MDTF and working with biometric systems, and people that have never been to the MDTF before. And then the counterbalancing, the order in which every group interacted with each acquisition system was sort of controlled and randomized so that every group didn't see a particular acquisition system first, and every group didn't see a particular acquisition system last. This is sort of to wash out, if they were learning how to interact with a biometric system on system A and then they got better on system B, well, the next time they would see system B first and then system A. So we hope that there wasn't any sort of habituation effect. So here's what the actual test population that participated in the 2019 Biometric Technology Rally looked like. There were 430 test volunteers that used every single acquisition system. In the upper left there, you can see they were almost evenly split, 50-50 males and females. Our age distributions are in the upper middle plot. You can see a pretty good spread from 18 to 81, maybe a little bit of a skew towards the 20 to 30-year-old demographic. Our self-reported race breakdown is the upper right chart. You can see we're about 45% Black or African American, 35% white or Caucasian, and then about 20% of people that identified as something other than those two. And then we also collected a few other things like height and weight as well. We presented this chart back in the original webinars that Jerry mentioned in November. This was sort of always out there about how we were going to evaluate these matching systems. And it was really on two things. Basically, their ability to template a biometric image that came from these diverse sort of acquisition systems that, to work with these images, and then to also match those images. And when I say match those images, I'm talking about correctly identify, so not a one-to-one match, but a 1 to n being our gallery size match. And that makes sense for this unattended high throughput use case, right? If you're trying to build a biometric system that takes less than 5 seconds, you're not going to have a component where you stop and present an ID or present a ticket. So it really has to be a 1 to n. It can't be a 1-to-1 evaluation. The galleries we used for that n are images that we've collected over the last 5 years at the MDTF. There's a gallery for faces, there's a gallery for fingers, and there's a gallery for irises. So different images in each gallery, but about the same size for each one. Each one had about 500 subjects. So this sort of figure down here in the lower right is what that looked like. If you were face matcher B, for example, we gave you this gallery, the purple box, and then we also sent every probe images that was collected from each acquisition system that collected face. So those all went into your matcher. We got true identification results out, and then we looked at those true identification results sort of across acquisition system, and that's this robustness measure that we talked about. We wanted to find matching systems that could do well no matter where their images were coming from.
Thanks, John. In operational biometric deployments, matching systems don't work in isolation. And the 2019 rally, for that reason, focused on evaluating operational-like combinations of matching systems and acquisition systems. And the key metric that we use to evaluate this performance is the true identification rate. We define this true identification rate as the percentage of transactions that result in a correct identity at a set threshold for each matching system. So as John mentioned, we're doing identification operations against our gallery. It's not a one-to-one verification, it's a one-to-n identification. So this true identification rate value was calculated separately for each combination of matching system and acquisition system. And this is a key point. If you're used to looking at NIST evaluations, you could think of this approach as, NIST separately evaluates algorithms on classes of images. For example, Visa images versus mugshot images versus selfie images. And so we separately evaluated each matching system using images acquired by each acquisition system separately. So a key point here is that each acquisition system gathered images on the same 430 subjects, which is not the case for the NIST evaluations. In our case, the same 430 people had a shot of getting an image acquired on each acquisition system in the rally, and each matching system had a shot of matching those images acquired on those acquisition systems. So for each system combination, the true identification rate was evaluated both excluding failure to acquire to focus on matching system performance. This is something that we won't focus on in this brief, and inclusive of failure to acquire to focus on sort of overall expected operational performance of the system combination. And this is really the key value because the total system performance is inclusive of all sources of error, both in terms of acquisition and in terms of matching. So how do we set this threshold? We actually fixed the threshold for calculating true identification rate at a setting suitable to generate a false match rate of 1 in a million. This was reported by each matching system provider separately to us. We did not do our own evaluation to verify that that's true. We just used what the matching system providers told us. The FMR threshold setting used for matching system performance was chosen such that the expected number of false positives observed during the rally is 0. And in fact, we had 430 volunteers, 76 of them were not in the rally gallery. And the correct behavior for any matching system for a volunteer that's not in the gallery would be to say that this volunteer is unidentified, that is, that doesn't have a mate in the gallery. So at a threshold of 1 in a million, the expected true negative identification rate should be 100%, so every one of those 76 should be correctly classified as being out of the gallery. And so conversely, the expected number of false matches is 0. So that's the threshold that we picked. The chart on the right just kind of shows you a theoretical curve showing the performance for true negative identification rate as a function of false match rate, and where different thresholds that we asked the vendor to provide to us would be set. And the one we chose, again, is 1 in a million. If you have trouble seeing the graphs, I recommend you to maximize the slide so that you have a better shot of being able to follow along, because there's going to be a lot of numbers after this. Here I want to pause and take a moment to go over how we're going to be visualizing these true identification rate results. For the 2019 matching system analyses, we're going to be focusing on true identification rates for each combination, as I stated before, of acquisition systems. These are the column headers in this little matrix that you see on the left. And matching systems. These are going to be the row headers on the matrix on the left. And each circle in the visualization is going to refer to one system combination. And now we can switch to the blue box and sort of take a look at inside. The black number inside the circle presents true identification rate performance, which is inclusive of any failures to acquire by the acquisition systems. That's the more operational measure of performance. There's also going to be a red number within each circle that's going to be more of interest if you're more interested in the performance of the matching systems in isolation. So I'm not going to go through those in a lot of detail today, but they're going to be there and available for you to look at. And I should note that every chart that we're going to present today during this webinar is going to be available at our website, mdtf.org, for you to look at your leisure, and all these tutorials for how to read the charts will also be available there. So the other metric that John mentioned that we computed for our matching system and for our acquisition system analysis is this notion of robustness. And as John mentioned, robustness really quantifies the variability in matching system performance across the acquisition systems. In fact, we quantified that very simply as the range of observed true identification rate values across systems. And we did that at a false match rate of 1 in a million. So if you have a number of different acquisition systems that supply images to your matching system, we're going to get a different true identification rate value for each system combination. And then for that matching system, we're going to take a look at the highest performance and the lowest performance and take a look at the difference between the spread between those two, and that's going to be our measure of robustness. So in this case, since robustness is measuring the variability, we're looking for low variability systems that give you the same high performance, ideally, across different acquisition systems, and so we want that robustness value to be low. Our goal for the 2019 rally was a 5% variation in performance at most across acquisition systems, and I should note that you could turn around this robustness metric and take a look at how robust are acquisition systems across different algorithms that work with their images, and that's another value of robustness that we can now report that's tied back to the acquisition system. So this kind of illustrates that a little bit better. If we take a look on the left, there are two plots there of a system that's not meeting the robustness threshold, and on the right is a different two plots that are both for a system that meets the robustness threshold, at least for discounting failures to acquire. So if you look on the left first, for this system, on the plot that's got a curve in black, that plot, you see that the performance, this is true identification rate on the y-axis, and you see that it varies quite a bit from acquisition system to acquisition system on the x-axis. And robustness basically quantifies how wide a variation that is. You see that bracket. And in this case, it's quite high, 61%. You could take a look at that counting failures to acquire, or just looking at the algorithm performance by itself, discounting failures to acquire. No matter which way you look, that bracket is really wide and the performance varies quite a bit across acquisition system. Whereas for the system on the right, you could see that, first of all, performance varies less, even counting failure to acquire. Now that bracket is only 32% high. However, discounting failures to acquire, you could see that the performance is uniformly very good. This system was able to reliably match images no matter which acquisition system those images were acquired on, and you could see that that variation is very small, just 1.2%. So this system met the robustness threshold. In fact, it met the goal, discounting failures to acquire. What we're going to show you is for each row, again, each row is associated with a particular matching system. We're going to show you some robustness values on the right margin for that matching system. And again, we're going to be using this sort of bracket notation to give you a sense of how much variation there was across acquisition systems in this case. And if we look at the chart on the right, that's actually the same chart as was on the previous slide for the system with good robustness. We'll show you two numbers, one for robustness without counting failures to acquire, and that's those red numbers, and one for the robustness counting failures to acquire, the black numbers. And there are three numbers that are needed to describe the robustness. There's the maximum level of performance. In this case, in both cases, was 100%. Then there's the minimum level of performance, the lowest tier observed across acquisition systems. In this case, it was 98.8% for the red numbers and 67.7% for the black numbers. And then that resultant range, which is just the difference between those two numbers, 1.2% for the red and 32.3% for the black. And those numbers will be present on that gray margin to the right. We're also going to take a look at robustness for acquisition systems. Those numbers are going to be similarly computed, but only looking at that one acquisition system now across matching systems, and they're going to be presented below each column. And to remind everyone, robust systems have smaller variation between pairs of systems, and low numbers indicate more robust systems. So you want those numbers to be low, closer to 1.2 than 32.3.
Evgeny, could you kind of reiterate the difference between the red numbers and the black numbers again?
Sure. Just to, again, reorient everyone, the red numbers specifically focus on matching system algorithm performance, and they discount any failures of a acquisition system to acquire the images. So while they don't describe the operational total performance of that system combination, they're relevant for specifically evaluating the matcher, whereas the black numbers focus in on total system performance inclusive of any failures to acquire or match. So these are probably what you would observe if you were first, say, to deploy that system combination in the field. Here's our first actual results slide. Let's take a look at the performance of fingerprint systems included in the 2019 rally. So if you've previously looked at acquisition system results at mdtf.org, either for the 2018 rally or 2019 rally, you should recall that we obfuscate acquisition system names. In this case, we used Rocky Mountain Peaks. And we obfuscated matching system names also to protect privacy of these companies. Here we used names of U.S. rivers. In the 2019 rally, we had 3 fingerprint acquisition systems. These are systems Gab, Foraker, and Baker. You could see those as the column headers. And then we also had 3 fingerprint matching systems, Iowa, Kansas, and Ohio, that are the row labels. And consequently, we've got 9 circles altogether, 9 system combinations, and each circle has a couple of numbers. Again, the black number is the main one we're going to focus on, which is the total system performance for that combination. The circle in green is the best observed performance, the combination with best observed performance, and you could see that overall, no fingerprint system combination met the 99% true identification goal when you count failures to acquire, and that green number there is the best total system performance that we observed, which was only 73.5%, which is well short of that 99% goal, primarily due to some issues with acquisition. However, further counting failures to acquire, the matching system with the lowest performance variation, that is the best robustness, was Kansas. It had a 5% variation in performance across acquisition systems. However, even though that variation was reasonably small, the net performance was typically between 60.5% down to 55.5% correct. So not a very good overall net performance. Again, looking at, however, acquisition systems and looking at the robustness of those, System Foraker was somewhat robust, and again, counting failures to acquire, Foraker achieved 2.3% variation, which is very low variation. However, again, many failures to acquire led to somewhat low performance estimates. The story for some of the matching systems by themselves in red is a little bit better, but I'm not going to go through those numbers. But for some of these systems, the performance was quite high, meeting rally thresholds. However, here we're focused on total system performance, so I'm going to let you kind of take that offline. Once the results are available on the website, you'll be able to go back and look at those. We could also, if you're interested, ask a question at the end of this presentation. We could go back and take a look at some of those numbers if you're interested. So next will be Iris systems. We had 2 Iris acquisition systems participate in the 2019 rally. These were systems Wood and Sanford. And we actually had 4 iris matching systems in the rally: red, black, white, and green. These are all US rivers. The best system combination for total system performance was the combination of system red and system wood, which achieved 82.8% true identification rate. Again, no iris system combination met the 99% true identification rate goal for total system performance. Overall, counting failures to acquire, the lowest performance variation for matching system was system green at 6%, and the acquisition system with the best robustness was system Sanford, which actually achieved very good under 1% variation, though on a relatively poor net level of performance due to a lot of failures to acquire on that system. So net takeaway here is the iris and fingerprint system combinations that we tested didn't quite live up to the goals of the rally. Now that we're used to reading these charts, here's a slide with a fair number of more bubbles. Again, this information will be presented on our website, so you'll be able to look at it at your leisure. And my purpose here is to sort of explain how the data is laid out and sort of major conclusions and takeaways. In the 2019 rally, there were 10 face acquisition systems, and you can see those as columns across the top. And there were 8 face matching systems, and you can see those as rows across the left side. Overall, the good news story for face, 4 out of 8 matching systems were able to meet the 99% true identification goal in combination with at least one acquisition system. In fact, for 4 of these matching systems, the performance was flawless with one particular acquisition system, system Teton. 5 of 8 matching systems met the 95% true identification rate threshold in combination with at least one acquisition system. And these are, just to orient you, these are going to be the filled circles, are those systems that meet, system combinations that meet the goal for the operationally relevant true identification rate. And the half-filled circles are those that meet the threshold but don't quite meet the goal. So you could see that 5 of 8 matching systems met the threshold. That also includes system Salmon, in addition to Pecos, Wabash, Trinity, and Mobile. 12 of 80 face system combinations met the goal of the rally, counting failure to acquire. 23 out of 80 face system combinations met the threshold, counting failure to acquire. And overall, looking at the robustness results, we see that matching systems were generally not very robust across acquisition systems when you consider failure to acquire, although if you look at just the images acquired, some of the matching systems performed very well and were able to match almost all of those images. So that's something to take a look at as well. Acquisition systems, in general, were not robust across matching systems, either counting or discounting failure to acquire. There was a lot of variation in the quality of the matching systems and how well they worked across different, across individual individual acquisition systems. What are some of the overall conclusions that we can take away from our analysis? So first of all, some matching system and acquisition system combinations worked perfectly in our test. That is to say that they matched all of the 430 diverse subjects, diverse test volunteers that used each system. That's actually a pretty impressive feat considering the number of places where errors could have creeped in. They could have failed to acquire, they could have failed to extract, and they could have failed to match. So flawless performance is very good. However, if we look across all the systems, all 97 system combinations across modalities that we tested, only 12% of those, actually 12 system combinations, met the rally goals. All of these were actually face matching and acquisition system combinations. And that should give some concern because all systems included in this evaluation passed subject matter expert review for inclusion into the rally and met all the rally participation criteria. So if you're putting together an operational system deployment, you're looking for acquisition systems and algorithms, matching systems to kind of combine, without some extra testing, your chances of success might be closer to 12%, which is not very encouraging. The rally for the first time tested a new notion, system robustness. How well does a particular system work across systems that it would likely be operationally paired with. So a matching system might be paired with different images from different acquisition systems. Or an acquisition system, those images might be matched by different matching algorithms. So some face and iris algorithms did maintain good robustness across acquisition systems, but others did not. No face acquisition system was robust across all matching systems included in this evaluation. So carefully picked matching systems may perform well so long as the acquisition system acquires images. However, some matching systems that did not perform well did not perform well, even with a good acquisition system. So our overall conclusion from our analysis is that system combinations must be carefully considered to achieve optimal performance in operations. With that, I'm going to turn things back over to Arun to close things out.
So first of all, thank you all for joining us for the webinar today. I know that we threw a lot of information at you. There's also a lot of numbers on some of these slides. We will have these charts available on mdtf.org, so you can go back and take a look at them at your own convenience. You can also reach out with additional questions, obviously right now during this webinar, but if you have questions later on, please feel free to email us at peoplescreening@hq.dhs.gov. So again, a lot of information here, a lot of discussion about this robustness measure. We were talking about it earlier. We realized that one chart on facial recognition systems, both collection and matching systems, there's about 600 numbers there. So we know that could be a lot to take in. We do value your feedback and your questions, so please let us know and we'll do our best to help answer those questions. With that, let's go to your questions. So the first question is, what would prevent a vendor from providing a generous threshold at a lower threshold to improve their accuracy, i.e. providing threshold for FMR at 1 in 10,000?
So I can take this a little bit. So Evgeny mentioned we had these 430 people that went through every single acquisition system. I think I mentioned we had a gallery of 500 people that we were matching back to, and 76 of those people actually didn't have any images in the gallery, so the correct response from the system was unidentified. If they had lowered their threshold, sort of arbitrarily or generously, to match more people, match more of the 370 some that did have images, they would have started falsely matching the ones that didn't. And so that was actually one of the points of that particular chart Evgeny talked to, which had the curve. It said, at what point would we expect 0 of the 76 people that were out of gallery subjects to incorrectly match someone? And the answer to that question was the 1 in a million threshold.
Yeah, so just to add to that a little bit, we did specify which threshold we used in these charts, and that was the 1 in a million. We did run some of these numbers with the 1 in 10,000, 1 in 1,000, and 1 in 100,000 thresholds. And as expected, at those lower thresholds, we started seeing false positives for some of the systems. One of the things we're analyzing, we don't have for you today, is how vendors are capable of picking their thresholds and whether the thresholds they report are the right ones to achieve a certain level of performance. In this case, we simply took it at face value that the threshold that should work at 1 in 100,000, 1 in a million is the correct one that they reported to us.
Next question. The finger reliability had lower black than red, but iris had the opposite trend. Can you comment?
This was in relation to the robustness numbers.
Yes,
Yeah.
sure. I think that some of the issues with the variation in fingerprint performance across systems, and I'm not sure if the comment is about robustness of algorithms or of of acquisition systems, but I could say that two of the fingerprint systems included in the Rally were non-contact and one was contact-based. So some of the variability in performance, especially with failure to acquire and failure to match, there was a complex interaction between somewhat higher acquisition rates for some systems and somewhat lower match rates for other systems. So it's a little bit, it would take a little bit of time to explain how those interactions summed together in total system performance and in only matching system performance.
Aside from the acquisition, what are the other essential inputs to building a highly performing face matching system algorithm?
So I think that
it might just mean face matching system. I think that's what the intent there is.
Yeah.
Okay.
So I think some of the issues that we see, especially with regards to robustness, there are some face matching systems in our evaluation that performed very well no matter what acquisition system the image was acquired on. However, what really started to separate some of the systems, some of the matching systems from each other was the ability to process images from some acquisition systems that could reliably acquire images, but maybe those images were not of high enough quality to match using that matching system. So I think that a highly performing face matching system should be robust across the different potential acquisition systems and the differences in image quality that those provide.
Yeah, I think maybe just an anecdotal story to sort of illustrate Evgeny's point there is that there were acquisition systems that spent a lot of time during the rally sort of trying to figure out how to position their camera. So one option is directly in front of the participant, so where they literally would run into it if they didn't stop. And that would obviously require a straight on, nicely framed image, but it would slow them down because they needed to go around it. And the other option is move that acquisition system off to the side a little bit, getting sort of an angled photo, which may or may not work with all algorithms, but would sort of speed up that total process of moving through there. So I think there's, just broadly answer your question, there's human factors considerations you have to think about. And then there's sort of these algorithm acquisition system interaction effects to consider.
Yeah, I would say, yeah, those are really important. I think if you are talking about a specific operation, you'd really want to focus on what is the concept of operations or the use. How are people supposed to interact with the system? I would start there first. You would want to pick the right types of cameras that may work in that particular type of environment, and then have matchers that work well across lots of different types of cameras, because you may have some variability with camera systems. You might go out and buy some cameras, and then later on some of them break and you have to get new cameras. There will be diversity in your cameras if you have lots of deployments. So it's kind of good to kind of think of it in those kind of pieces, perhaps.
Just to add one more thing, there's lots of variability in lighting, and there's lots of variability in how these cameras behave with differences in lighting, and that's another consideration.
Next question. Given that selecting a winning system combination is low, when will business requirements be published for airport operators? I think this is a little bit of a targeted question, but what I will say is, right now, with the results as we publish them, we have applied aliases to the different company names. So aliases are given, so Rocky Mountain Peaks for collection systems, Rivers for matching algorithms. That being said, if there are combinations of collection systems or matching algorithms you are very interested in, you can email peoplescreening@dhs.gov, and we will forward your email to those companies so that they can follow up with you directly, so that you can understand which companies are performing. And actually, I think that goes to the last question that was just asked as well. Will you be able to share the actual names of vendors you held to an NDA? So we're not actually providing the vendor names, but what we will do is vendors who are very happy with their results may self-announce. This is what happened last year, where some companies did press releases and they said, we were company X, we were company Y. But the other thing we offered was, if there is specific interest in a company, Again, email peoplescreening@dhs.gov. Tell us which companies you want to reach out to. Please don't say all of them, and we're not going to take those seriously. We're trying to abide by the terms of our credas with these companies. So if you give us a list of, let's say, 2 or 3, we will forward your email to those 2 or 3 companies so that they can follow back up with you, and hopefully answer your questions or share more information about their products. Next question. Were any of the matchers and systems from the same vendor such that they might be better optimized? Good question.
Yeah, so I actually was taking a look at this recently. There were a number of matching systems and acquisition systems that were from the same company. If Arun tells me I can say it, I'll tell you exactly how many. And there were a majority of those that actually had acquisition systems that did better with someone else's matcher. Yeah. That was not uncommon. So I think there is definitely the room for this sort of matchmaking process, as Arun likes to call it, where there might be opportunity for partnerships and sort of collaborations out there.
Yeah, and I would add to that. So we did definitely obfuscated matching system names differently than acquisition system names. So you won't be able to just look up the same alias in the row and the column on any of the charts that we put out. So I think if you want to know some of those combinations, we might have to reach out.
Okay. Next question. So, in my knowledge, face image acquisition rate is changed depending on the camera configuration. Does S&T have any camera specification standards for the estimation of FTA? I would say, I think the answer to that question is no. I think the point here is the face acquisition system configuration really needs to be tailored to the ConOps or the use case. Depending on the use case, you have a specific intended behavior of the user, as well as what the camera is expected to do. This will vary from system to system depending on the specific use case. And depending on that use case, you can kind of tailor these systems, pick the right type of camera system. So to be honest with you, the Rally is really intended to, if we're describing it in terms of specific DHS type use cases, it would work primarily, I would say, it's really targeted for like an exit type of scenario, or maybe like a TSA travel document as you're approaching the travel the TSA representative. That would be a relevant use case. Another one might be if you're just approaching just a general security checkpoint, and you kind of have a direct line entering the system. For other types of use cases where you might have a camera off to the side or above, or something like in a CCTV camera system, I wouldn't use the same camera. So you really need to kind of select the camera, the position, and the interaction based on the specific scenario. And I wish I had an easy answer. It's like, oh, yep, go to aisle 3 and pick any camera there. We're not to that point where these technologies are fully commoditized. You have to, you need to do some careful selection here. And I think the results of some of this, what Yevgeny and John talked about, kind of highlight the fact that there really needs to be some careful selection if you're using these different camera systems, especially with different matchers. Anything else to add there?
Maybe just one little point. So we didn't really have a ton of input into how those cameras were configured, right? We were very open and transparent with our test design, and this is exactly how we're going to test your images. All those slides about the process and the number of people and what exactly this would look like, they've been up on our website and presented at webinars since November. And then camera providers, acquisition system providers, actually got to set their configuration to whatever mode they thought would give them the best performance. And I think that's a lot of times, although maybe not always, typical of what you'll find in the field as well.
Yeah, there are many reasons for why an acquisition system might have high failure to acquire rates, and these reasons might be different depending on the use case and the technology. So sometimes it's a challenge in terms of usability. Does the volunteer know where to look? Sometimes it's an ergonomics challenge. Is the camera configured so that the volunteer can get into the frame? Sometimes it's a lighting challenge. Can the system acquire an image in dim light. So although we previously make the statement that failure to acquire is the highest single source of error, underneath that there are many different causes for failures to acquire, and that makes it challenging to give one prescription for how to solve that.
Yeah. I think one thing to add, we did give the vendors the opportunity during the first 2 days to make human factors changes to try to improve the performance of their acquisition rates.
And frankly, one thing that was that we did observe and we continue to observe is, in addition to robustness, there's a general issue with system reliability. Some of the acquisition systems experienced technical failure during testing, and that dinged their acquisition numbers because if the systems weren't on, they weren't going to capture any images. And this was an issue for some systems in this 2019 rally and also for several systems in the 2018 rally. So that continues to be an issue.
All right, next question. To your knowledge, did any of the algorithms utilize multi-image templates, or was this outside the test design of this rally?
Yeah, so I know no algorithms utilize multi-template images, I think is the way to answer this. So if we go back and look at, I forget exactly what slide, but it talks about the matching system requirements. There isn't an opportunity to provide multiple templates per an image. Our API specifies image in, template out. And that's still up on github.mtf.org if anyone's really interested. It's a little bit different from some of the NIST APIs that sort of allow you to create this gallery. I think that's for optimizing speed purposes, and some of the IARP APIs, which sort of let you build this super template concept. We don't have any of that.
Next question. Were the acquisition vendors allowed to recalibrate the system after an initial period of capture, i.e. after 1 day? So the answer is yes. I think it was after 2 days. They were allowed to make we called them human factors adjustments over the first 2 days.
Yeah, over the first 2 days they could adjust any sort of signage or layout of their station, after which they had to freeze that. However, they always had an opportunity for break fix in case their system experienced a technical issue. They could go back after the group of participants had gone and see if they could get their system up and running again.
Yeah, so I should probably provide a little context. So during the first 2 days, what that really meant was that the vendors who were participating could monitor the performance of their systems. We actually gave them iPads so that they could see videos of people interacting with their systems, as well as see some of the imagery coming out of their systems, so that they could determine whether or not the system appeared to be working correctly based on their own expectations. So for example, if people weren't doing something and they had instructions out there, they could go back and say, well, maybe I should change my instructions, or if they saw people looking in the wrong direction, maybe they could reorient or reposition things. So it was really up to the companies themselves to see whether or not what they put within that 6 by 8 square foot space was eliciting the behavior they were looking for from the people, from the volunteers interacting with the systems.
In fact, several systems did take advantage of that and change signage to, for example, to better deal with people wearing glasses.
And I think that includes, to answer the next question, camera capture settings were part of that, right? So if you wanted to change how many pixels between the eyes before you would capture a picture, you could do that in the first 2 days.
Yeah.
Yeah. I think the major point there is for that, that was left to the vendors. We basically provided a fair playing ground, a fair set of rules, and it was up to them to figure out how they would innovate across the different variables they had available to them to adjust and figure out how they would adjust their own system to meet the goals that we had set forth. All right, so next question. This is more of an acquisition question, and I have not visited MTTF, but were lighting conditions equivalent for acquisition systems regardless of physical location? Were lighting conditions changed during the rally? Good question.
So yes, I could address this. So all rally stations were designed to be identical, including the lighting conditions at that stations, which were calibrated to be 600 lux. And that ensured fairness in the design. There were a number of other things that were included in the design to ensure fairness and habituation, and John mentioned the counterbalancing as well. So yes, the conditions at each station were kept as constant as possible.
Well, I think we're right at the end of our webinar today. So again, we don't want to cut things short. I'm sure that there are probably more questions. If nothing else, I'm sure you did not have enough time to look at those charts with all of those numbers, those great numbers. Please, so we will put those up on the website. They will be there by the end of the week. Please feel free to take a look at them, and I'm sure you may have more questions. Again, we welcome your questions at peoplescreening@hq.dhs.gov. Thank you, and have a great day.
Thanks, everyone.